My name is Ribahende Flores and this is my channel. Good day everyone. So for today's video, let us discuss about derivatives, specifically the higher order derivative. So as you observe, the objectives of this video was to help us apply the basic rules, which is specifically the power rule, the constant rule, and the third one, which is the fuse of the two, which is the exponent and constant rule. So without further ado, let's go started with this video by knowing the notations we can use to denote the derivative of the given equation. So would be the notations. First is the derivative of a function can be denoted as f of x y prime dy over dx, or dy with respect to dx, f of x with respect to dx, f of x, or d big letter d, and f of x. So these are the examples for us to apply the first rule, which is the constant rule, which is understood that any constant would be equal to 0, and then the exponent rule, which is you must multiply the exponent to our coefficient, and then the exponent would be subtracted by 1, and so on. Then the last one would be the fuse of the two. So this would be the examples of solving or finding the higher derivatives of a given function or equation. So first is find example number 1. Find if y is equal to 3x raised to the power of 5 minus 2x, find y, or the fourth term or fourth derivative of the given equation. As you observe, we have 4 here. 1, 2, 3, 4, right, as 4, 1 raised by y. So solution. First is the given. We need to rewrite the given, since the given is in the last slide. So to avoid conflict, we must rewrite the given, which is y is equal to 3x raised to the power of 5 minus 2x. First derivative of the given function, 15x raised to the power of 4 minus 2. As you observe, why we came up with 15x 4 minus 2 is it because of this process. As you observe the given, we have raised to the power of 5, so we must multiply the exponent, which is 5, to our constant, or the coefficients of the variable x, which is 3, so we came up with 15. And then it is said that in a basic rule derivative number 2, which is we need to subtract 1 if we apply power rule. So we came up with 15x raised to the power of 4 as we subtract 1 to 5. And then here, minus 1, 2, we came up with constant 2, since it is understood that x itself has its exponent, which is understood as 1. So we need to multiply the 1 in the given coefficients of x. So we came up with 1 times 2, so 2, and then 1 minus 1, then we eliminate the variable of 2, which is the x only. So the next the second derivative of this given equation would be equal to 60x cubed. Is it because of this process? Since the new given here is the first derivative, since if finding the higher derivative of the given equation is that we must continue the process. So from 15x raised to the power of 4 minus 2, we came up with 60x cubed. Is it because we multiply 4 to our constant, which is the 15, so we came up with 60, and then we subtract 1 to our present exponent here in the first derivative, which is the 4, so we came up with cube, or the power of 3, minus 0 or nothing. Is it because of the existence of the first derivative rule, which is the constant rule, that any constant must be equal to 0. So the third derivative of this given equation would be 180x squared. Is it because of this process? Again, we apply the exponent, or we must apply the applicable rules. So from the new given, which is the second derivative, from the second derivative, which is the 60x cubed, we bring down, or we multiply the number himself, or the 3, to our constant in a second derivative, which is 60. So we came up with 3 times multiplied by 60, so we came up with 180. And also, as a rule, we must subtract 1 to the power, so we came up with x squared as in the third derivative. Next derivative, or the last derivative, since we are asked to find the fourth derivative of the given equation, and that would be equal to 360x. Again, we apply the any rules applicable to the given. So we came up with 360x. Is it because we multiply, or we bring down 2 and we multiply it to the given coefficients of x squared, which is 180, so we came up with 360. And x, for that we minus, or we subtract 1 from the present power in the third derivative, which is 2, so we came up with x. So the final, or the fourth derivative of this given equation would be equal to 360x. So it is an infomat that the power itself would help you, or serve you as a guide in finding the highest derivative. Is it because if we are asked to find the seventh derivative of this equation, then it is understood that would be equal to 0, since the highest power of this given is just a 5, and then we are asked to find the seventh derivative, so it is expected that it is 0, equal to 0. So next example, for us to erase the doubts, or the doubts we have from the previous example. So the second example would be find the fifth term, or for fifth derivative, if y is equal to x raised to 4 and then minus 3x cubed plus 2x minus 5. So as you observe here in a given example, we are asked to find the fifth derivative of a function, which is the power, or the highest power is just a 4. So it is just like proving the theory, or the infomat I have shared to you, which is I just also learned from our discussions. So let us see if the infomat is correct. So the solution, again, let us rewrite the given, which is don't confuse with the dy with respect to dx. Is it because it is one of the notations of denoting derivative. So we have this 2x raised to the power of 4 minus 3x cubed plus 2x minus 5. So the first derivative would be d prime dy with respect to d prime x. so is equals to 8x cubed minus 9x squared plus 2. Is it because of this process here? We apply the rules which is applicable for this to solve for this equation. So we bring down 4 and then we multiply it to the constant or the coefficients of x raised to the power of 4, which is 2. So we came up with 8x cubed, since we need to subtract 1 from the from the base of which is 4. We need to minus or subtract 1. So we came up with 3. The next one would be just bring down 3 and multiply it to the coefficients of the second term here in the given, which is 3x cubed. Coefficient would be 3, so we came up with 9, and then subtract 1 from the coefficient, which is 3, so we came up with negative 9x squared. Here again, the rule, it is understood that x has its exponent understood as 1, and we multiply it to the 2, so we came up with 2 plus 2, and then negative 5 is constant, so it is automatically would be equal to 0 based on the constant rule. So the next derivative would be 24x squared minus 18x. Is it because of this process? We multiply 3 to 8, the coefficients from the first derivative, which is 8x cubed. So we came up with 24x squared as we subtract 1 to our degree, or to our power, which is 3. And then we minus 18 as we apply also the power rule that we must bring down 2 and then multiply to our coefficient to the second term in the first derivative, which is 9. So we came up with 18, and then we subtract 1 to our power, which is 2, so we came up with x. And then it is understood that 2 is constant, so it would be equal to 0. Next derivative, the third derivative would be 48x minus 18. Is it because of this process? Again, we bring down 2 and then we multiply it to the given or the coefficients of our x squared from the second derivative of the function. So we came up with 48 as we subtract 1 to our squared, so we came up with the remaining x. And then minus 18, is it because of the 1 multiplied by 18, so we came up with 18, and we eliminate the x. Next, the fourth derivative would be 48. Is it because of this process? Is it understood that x has its coefficient, which is 1, power, which is 1, and then we multiply it to the coefficient of the third derivative of x, which is 48, so we came up with 48, and then we eliminate x. And then for the negative 18 in the third derivative, it is understood that it is constant again, so we must, or we can, we already understood that it would be equal to 0 since constant rule exists. The last derivative of this given function is the fifth derivative, since we are as the fifth term or fifth derivative of the function. Function 2x raised to the power of 4 minus 3x squared minus plus 2x minus 5. So the fourth derivative would be equal to 0. And then is it because, as you observe in the fourth derivative, it is constant, which is 48. So it is expected that it is 0 as we find the fifth derivative of the function. So it is also correct, the MFOMAT given. I've shared to you that I have also learned from our instructor, okay, it's Mr. Cuneda, and I hope you learned from this video. And if you like, please do subscribe, and thank you.